Thanks for joining us and taking time out this morning to be here. I'll tell you one thing, it's hot already. We might need a little solar eclipse later in the afternoon just to cool things down. So let me go back again and talk about why we're here. If you take a look at that, the eclipse has already probably started somewhere up by Oregon, and it's racing. If it's out in the ocean, it's racing towards us, and it'll be here, the totality, about 1 o'clock our time, 1:15. It'll be around 2:15 in Indiana. And you can see along that path, it's kind of an interesting graph because it matches all types of states and starts in the northwest and goes all the way out into the Atlantic Ocean, close to South Carolina. So it's going to be kind of an awesome event. People from all over the world have converged on this Great American Total Solar Eclipse. It's called the Great American Total Solar Eclipse because we're the only country it's going through. It's going to transverse the entire country, making it pretty special for us. Now, if you notice that people along the path, even in southern Illinois, we can show you the map of our southern Illinois, we're going to get a really good view of the umbra. That's the shadow that is from the light source, the sun, and the moon blocking it out. And so let's just talk a little bit about the solar eclipse. I think we have an image that we're going to put up, and it's taken with a special filter. And if you look at that image, you're actually not seeing the sun. In fact, you should never look at the sun. Even for a brief period, it'll do some damage. What you're looking at is the moon in front of the sun. But we're actually seeing there the corona, or the chromosphere, which is like the atmosphere of the sun. Scientists are really excited about seeing that because you don't get to look at it. It's also a very strange place. It's several times hotter than the surface of the sun, which is hard to understand. That's one thing they hope to explain today with all their instruments. How can the atmosphere be actually hotter than inside of the sun? But it is. Now I'll tell you, let's take a look then at the alignment. Now that alignment shows the sun, the moon, and the earth. And years ago, hundreds of years ago, a total eclipse was some science evidence that, hey, we did rotate and we did orbit around the sun. And that's called the heliocentric, helio meaning the sun. Up until then, people used to think it was the geocentric, that everything went around the earth. So when you have a total solar eclipse, whether it's myth or science, it's an interest to a lot of people. Now, if you check that out, you'll see that it almost looks like an ice cream cone turned around backwards, and the bottom tip of that ice cream cone is what's touching the earth and making the eclipse, or the blockage of it. So you see the diagram, you guys have studied that. It's a really cool thing to study. Later on, we'll be talking about the difference between a solar eclipse and a lunar eclipse. I'll tell you, I would like to show you the sun though. This is an image that some friends of mine back in Indiana made for me, and you see all kind of interesting things, flares, sunspots, and maybe today we're going to even see some more cool things that you see from the sun here. And it's hard to believe, but this sun is 400 times bigger than the earth. We'll talk more about that a little bit later. And so the scale of this sun is pretty amazing. And once again, if you're going to observe the sun today, do it in a safe manner. Make sure that you never look directly at the sun. And I'm going to keep my solar glasses handy here, because these are special glasses. They're not sunglasses, and they are coated with a material, and I can put them on and look at the sun over my glasses. If I look at anything else, they're totally dark. But if I put them on and look up, I can see a beautiful yellowish disc, as round as can be, 93 million miles from here. And we have some videos some of the students in the schools have made for us to explain that a little bit better. So we look at the sun, we take it for granted, we go outside every day, but there's some people that make their living studying the sun. And a lot of those work for NASA. They're astrophysicists. Now you take those two words together, astronomy and physics. It's both studying the things in space and how they move and their energy. You put those together, you have astrophysics. And really, it's a lot of math. And math that actually, calculus, that was started back with Isaac Newton. Isaac Newton, Sir Edmund Halley, an astronomer, a mathematician. Maybe they invented astrophysics. I'll tell you what, we have a chance to meet a real NASA scientist, Dr. Sten Oldenwald, who is a director of citizen science. Citizen science is an amazing way that you can be involved in real science. You can go to their website and get involved. He is also an astrophysicist, and he studies the cosmos, the stars, the orbiting, the nebulas, and all those cool things. Let's see what Dr. Oldenwald has to say for us today. I'm here with a NASA scientist, Dr. Sten Oldenwald, who is from Goddard Research Center, and he's here to study the eclipse like we are. Welcome.
Well, it's nice to be here with you and everybody on the other end of this program.
Yeah, thanks. We're broadcasting back to Indiana, and there's a lot of teachers and a lot of students. And so you're a NASA scientist. How is NASA studying this particular total eclipse?
Well, you would think that total eclipses would be kind of boring for astronomers these days, but they're not, because we don't really know as much about the corona of the sun as we'd like to. So NASA, we've deployed a couple of spacecraft too, yes, but certainly aircraft that are going to be traveling at supersonic speeds to keep up with the shadow. That helps us prolong how long we can actually observe the corona, which we hope is going to be at least an hour. We also have, through other programs, a series of balloon launches that will let us knit together a single movie of the corona that'll last about an hour and a half. So we're going to be able to see things moving around that we've never seen move around before, and that's going to be very exciting. I mean, you know, the research is so primitive. You know, if you see something moving, that's exciting.
Yes,
because before you didn't ever see anything moving. So now you get to theorize about what that's all about.
And I know that in the past you've learned things from the corona. And so what are some of the key marks that we've learned?
Well, one thing that we've learned is that the corona doesn't have the same shape during the sunspot cycle. It changes during the sunspot cycle, and when you study total solar eclipses, you get a snapshot. Since there are about 2 total solar eclipses every year, you get kind of a snapshot of what the corona looks like during the solar cycle. We now want to get a movie going. It's not going to cover the whole solar cycle, but it'll at least give us some indication of how it changes in a short period of time, and work our way up maybe eventually to the longer period of time as well.
I understand that these aircraft are going to go supersonic speed, because they're going to be looking not at the umbra. We're all excited about the umbra, but you're going to be looking at the corona.
That's right. Basically, the shadow of the moon projected on the Earth travels about 1,800 miles an hour. So that's like, you know, Mach 1.5 or 2. We originally did this kind of a study back in the early 1970s with the French Concorde supersonic transport. And there we got basically 90 minutes of continual observations of the corona of the sun. And that taught us that the corona, pieces of it do change in very complicated ways. And now with this new approach, not only the balloon platforms, but also with the jet planes, we're going to extend that to an hour and a half. You know, you make small improvements, and every time you do that, you learn something new.
So you're actually interested in studying the sun all the time, and this is just a special time. So when there's no eclipses, how do you study the sun?
Well, the way NASA studies the sun is, well, we've got these really great satellites that can image the surface of the sun and also the brighter parts of the corona. There's 3 or 4 that do this around the clock. The Solar Dynamics Observatory gives us high-definition video at a variety of wavelengths, which lets us look at different temperatures of the plasma on the sun and how they change literally from minute to minute at very high resolution. We also have coronagraphic instruments which let us block out the bright light from the sun and study features in the corona that change, things like coronal mass ejections, prominences, helmet streamers, and things like that.
Those are very cool. I've read about these and seen some of these. What are the chances of seeing one of those coronal mass ejections tomorrow? What do you think?
I think, you know, it could be sort of 50-50. I don't know. one thing that we have going on right now is we have a fairly large sunspot group that's nearing the center of the sun, as seen from the Earth. We know that that sunspot group has produced a couple of very good flares, one M-class flare not too long ago, and that seems to be sort of a typical breeding ground for coronal mass ejections. And if that thing were to let fly with one, it would be basically, we'd be right down the barrel of the gun.
Wow.
So that's something to keep watch on. Whether we would be lucky to see that at the exact moment of totality, probably not.
But we can always hope.
We can always hope, yeah.
So back here on Earth, we know the sun is important for photosynthesis and weather and light. When you were a kid, did you ever think you would be studying the sun?
No, actually, because I'm a cosmologist and I study the universe. My education work is in solar physics and things like that, and I've learned about that community quite well. I work on studies of the evolution of the universe and galaxies, and this is just an exciting area for me because, unlike cosmology, this is a subject that changes from day to day. Literally changes, as the sun changes. And I kind of like that now.
Yeah. And that's kind of neat because this is something that's there every day that we see and often take for granted, but not tomorrow.
No, absolutely not. We should see some really interesting things with the corona. There's a prediction from satellite observations in the last couple of days that we should see some pretty bright plumes coming from the sun. So that'll be worth looking at.
Well, I'm excited for it, and I'm excited for the kids and the students back in Indiana because we're going to be seeing the same eclipse just from a different angle. Thanks a lot for your time.
Oh, you're quite welcome.
Hi, I'm Mrs. Rampersad, and I teach some great kids here at Bridgeport Elementary in Wayne Township. There's a lot to learn about the Great American Eclipse of 2017.
You know, the sun and the moon look about the same size in the sky, right?
That can be deceiving because the sun diameter is actually 4 times wider than the moon.
But the sun is 400 times farther away from us. That is why from the Earth it seems the sun and moon are the same size.
Thanks for the information.
3.
Let's see if you can make the moon seem like it's covering the sun. Did we do it?
Yeah.
Now you know.